Alright, so let's start here with this example. We have 4 plus 2 cosine of 1/3 x minus pi over 6. So there's a lot of different transformations going on here. We need to come up with a good strategy for actually sketching this thing, okay? Now, we identified the amplitude as 2 because 2 is the coefficient in front of the cosine. And we had got the period to be 6 because b is 1/3 here. And we know that the period is always going to be 2 pi divided by whatever b is. Okay? So 2 pi divided by 1/3, you flip and multiply, and you get 6 pi. Okay?
Can I let you dress in?
Yeah, there you go.
Thank you.
Alright, so there's our amplitude and period that we already have. Then we have the translation. Okay? I usually will just write the translation kind of as a point, and that way that's telling me the origin, where the origin would move to, and then I can gauge everything else off of that. It actually, looking at it this way is looking at it in terms of a translation vector. Okay, so, and we're going to deal with vectors later on, but we have a translation here, and what's the vertical translation, since that's the easier part here?
4.
It's 4. We're adding 4 to this whole cosine function, so this whole thing is going to be shifted up 4, but then how do we figure out the horizontal translation, that h, if you will?
Oh, it's a 2. Sorry.
It's what?
You're looking at 2? 4.
No.
It's pi over 6 over 1/3.
Okay, remember it's the c over b.
Oh, yeah.
C over b, h is c over b, so that is pi over 6 divided by 1/3. And you simplify that and you get pi over 2. So our entire thing here is shifted over pi over 2. Okay. Now, identifying all of that obviously is the first part. The next part, and in some ways it's even a more challenging part here, is just getting our sketch to look decent, okay? The first thing that I would do is, because this thing is translated up, anytime you translate it vertically, what I would do is draw my center line, okay? We talked about this like midline or center line. Basically, you guys know the sine and cosine goes up and down around the x-axis normally. But when we shift it up, it's like that x-axis gets shifted up as well. Okay? So what I like to do is I'll just draw myself a dotted line there at wherever we were shifted up to. And then I can gauge from there how far up or down I have to go. It's going to go around that line instead of around the x-axis. Okay? Then what I'll do is I'll identify kind of where my origin went to. Alright? My origin is going to go over pi over 2, and it's going to go up 4. So here's like my point of reference that I can graph everything else from. Okay, that's not a point on the graph in this case, but it's kind of helps us see where the new origin is, if you want to call it that. Okay? Now we have to think in terms of our cosine function, and I'm going to get the 5 points, and then we'll figure out what the actual coordinates of those points are. Okay? First of all, where does cosine normally start?
At the top of the amplitude.
At the top of the amplitude. It normally starts at 1. In this case, with our amplitude being 2, and since we're shifted up 4, I've got to go up 2 from the 4. So this right here is going to be the first point.
Pi over 2, pi over 2, 6.
Okay, yeah, that's pi over 2, 6.
And that's because you moved pi over 2 to the right, and then 4 up, and then 2.
Yeah,
Okay.
yeah. Alright, so then we have to think through our cosine function. At the next point, whatever that is, where am I going to be?
1/4 period over.
Yeah, don't worry about the period right now. Where are we going to be vertically at least?
Down.
Down.
Where? We need 1, 2, 3, 4, 5 points, right? So maybe we should start at the end, okay? If we're here at the beginning, where are we going to be at the end?
Same spot. Or
Yeah,
six.
up at 6, okay? We're going to be up at 6 at the end of the period. Let me a little better. Okay, so there's that. In the middle, where are we at?
You're at the middle at this.
What's our y coordinate?
4.
No.
2.
Oh, 2.
In the middle, we're at the bottom of the amplitude, which is going to be 2. It's 2 units down from 4. Okay? Then where are we halfway between these?
4.
We're at 4. Okay? And halfway between these, we're at
4.
4. Okay? So we actually can sketch it right now, but we do need to figure out, hey, what angles are these down here? We need to figure out our x coordinates. So here's where our period comes into play, okay? We think through our period and we say, okay, if we're starting at pi over 2 and our period is 6 pi, all right, this distance here has to be 6 pi. What would this be?
Pi over 2 plus 6 pi.
13 pi over
Yep.
2.
Yeah, pi over 2 plus 6 pi, 13 pi over 2. Okay?
And then would the one in the middle be 6 pi over 2?
Close.
3 pi.
You'd average them.
Oh, it would be 7. It would be 14 pi over 2. It would be 7 pi.
It'd be 7 pi over 2. Okay? We're going to average these two. Average your beginning and ending coordinates, and that'll tell you where the middle is. So 14 pi over 2 divided by 2 is 7 pi over 2. Okay? What's halfway between pi over 2 and 7 pi over 2?
It would be 2 pi.
Okay, 2 pi. Because you have 8 pi over 2, which is 4 pi, divided by 2 is 2 pi. And then what's halfway between 7 pi and 13 pi?
5 pi.
Okay, 5 pi. 7 and 13 is 20 pi, divided by 2 would be 10 pi over 2, which is 5 pi. Okay? Now, another way some people like to do this is what they'll, instead of trying to do first, last, middle, and then middle, middle, what they'll do is they'll look at the period and they say, hey, we need to cut this into quadrants, so let's cut this, divide this by 4. 1/4 of 6 is 1.5 pi. So then they'll say, okay, 1.5 pi.
You just
A
have to
half plus 1.5 is 2 pi. 2 pi plus 1.5 is 3.5, or 7 pi over 2. 3.5 plus 1.5 is 5. 5 plus 1.5 is 7.5, or 13 pi over 2. It's up to you which way you want to do it, but those are kind of the two easiest strategies there. Okay? Now, as long as you are neat in labeling these, and in labeling your axis here, you don't have to label every individual point, okay? But make sure that you're being neat and it's very clear where your points are, okay? All right. Now, that is the situation we've got when we're given an equation and we're trying to graph it. Another thing, and this is a little bit more of a realistic type of situation, is when we're just given data And we know it follows a periodic function. It follows a sine curve. But we need to figure out what the equation of that sine curve is. And if we could do that, then we're able to use that model to predict certain things. Okay? So we're looking here, we'll get to part B in a sec, but we're looking here at a situation where it says throughout the day the depth of the water at the end of a dock in Bangor, Washington varies with the tides. Okay, so the tide comes in, the water gets deeper, the tide goes out, the water gets shallower. Okay, we're near the ocean, that's something you're probably a little familiar with. Okay. The table shows the depths in feet at various times during the morning. So you can see here, at midnight it's 3.1 feet deep. At 2 a.m. it's 7.8 feet deep. At 4 a.m. 11.3. Okay?
It's a pretty big change.
And so on. Yeah, there's a pretty big change. In fact, you can see here, to get from the highest point to the lowest point is, from 4 a.m. to noon. Okay? Now, if you look here, you'll notice they sketched this data and they're trying to fit it to a curve, fit it to a model, and they're not, you'll notice they're not assuming that this is the peak right here. Okay, in order to figure this out exactly, we would want to measure like kind of throughout the day and figure out when the very highest and when the very lowest points were. Okay? But in order to use a trig function to model the data, we've got to figure out a couple of different things. Alright? First of all, we need to decide whether we're going to use sine or cosine. The reality is, it doesn't really matter. Okay? It really doesn't matter. Now, there may be parts where, based on our data, it's kind of easier to use one versus the other. But this is where, make sure you use a cosine curve. But in this case, they don't give us one or the other. So we can just pick one. And for this one, actually, I'm going to use a cosine curve. All right? So I'm going to make y equal to d plus a cosine of bx minus c. Okay? The key here is we've got to figure out what each of these is. All right? So let's look at our data. Based on the data that we have at 4 a.m. 11.3 feet deep. That's the deepest that we've got. Okay? So, at noon, we have 0.9. Okay?
So does that mean the whole thing shifted up 0.9?
No. That would be like the lowest point in our amplitude. Okay? Now, let me double check one thing because I think I might be missing one part of the problem. Okay, no, it's not. Alright, so what we have here is, the first thing that we can find is our amplitude. Okay? And by identifying our max and our min, we can figure out the amplitude. Alright, so what would the Or how would we find out the amplitude?
Add them together and take the average, or divide by 2.
Okay, we want distance, right? How do you find the distance between them? What?
You subtract them.
We're going to subtract them and divide by 2. Okay? Now, we are going to average them. What would averaging them, adding them up and dividing by 2 give us?
The midline.
The midline, which is also going to be what in our equation?
The vertical shift.
The vertical shift, okay? So watch this. When we do 11.3 minus 0.9 over 2, that's going to give us our amplitude, okay? That's going to give us our amplitude. All right, so that's going to be a, what, 10.4?
5.2.
Divided by 2 would be 5.2, okay? So 5.2. And then also, D, that vertical shift, is going to be the average of the max or min. Okay? So it's going to be 11.3 plus 0.9 over 2. Okay? So that's going to be 12.2 divided by 2, that's 6.1. Alright? Does that make sense? Okay? So right here is our midline. That's the 6.1. And the distance from that midline up to the top or from that midline down to the bottom is going to be 5.2. Okay? Alright, does that make sense? Not getting any response at all. Does that make sense or no? Are you totally lost or? Okay. Okay. This is not the kind of thing you want to get lost on and get behind. Alright, so make sure you're asking questions along the way. Now, the next thing that we need to look at is this, okay? We need to figure out what the horizontal shift and what the period is going to be, okay? We need B and C. Those are the only two parts of our model that we're still missing. So to get B and C, those are both related to our period. And if you look here, can anyone tell us how we might figure out what the period is, just in like hours? We're not getting B yet, but just in hours, what's the period of this function?
Oh, like 16.
Why do you say that?
Because it just keeps going up by 2, and then to 12 it's 12, or yeah, to 12 it's 12, and then 3.1 isn't really close to 1, so I added 1 more. Just kind of guess.
Kind of guess. Okay. Can anyone come up with a little more mathematical theory than guessing? Alec?
This is a shot, but 2 pi over 3.1. So like.
No.
Over 1.55.
No. Luis?
Is it 2 p.m.?
What do you mean is what, 2 p.m.?
The period ends at 2 p.m. It starts at midnight and ends at 2 p.m.
It starts at midnight, ends at 2 p.m.
Mm-hmm.
No, not quite.
Well, 15.
Is it 2 p.m.?
16.
Think about this,
I
guys.
need 3 to
We know where the max and min are, right?
Yeah.
When do the max and min occur?
Oh, in the middle. So if you find the distance from the
And that's what it is. So like,
Hang on, just keep it simple. I'm just asking a simple question. When do the max and min occur?
4 a.m. to 12 a.m.
Halfway
4
between the
a.m. to
period.
12 a.m. Okay, so this time period right here, from here to here, is 8 hours, right? So,
16,
so why are you saying 16?
because it's one period have one down, one up. So it's like-
Okay, yeah. Cosine starts up at the top, it goes down, and then it's got to come back up, right?
Yeah.
And if it took 8 hours to go all the way down, it's going to take 8 hours to go all the way back up if this is a cosine curve, right? So our period, okay, this is half of a period. So our period is going to be that 16, all right? 16 hours. Okay?
4 to 16.
Does that make sense?
But it's from 4 to 16 or from 2?
Well, it would be 16 hours from
Oh, listen, man.
from 4 a.m. And actually, what we're identifying here too, what is our 4 a.m. going to be in relation to our graph?
It's gonna be like the start of the cosine function.
Yeah, it's the start of the cosine function, so that's our horizontal shift, right? The horizontal shift, h, is 4. Hi. Hello. Okay? So this is what you've got to think through here.
What if I sine from midnight to 4?
Well, the only problem with that is that midnight doesn't give us a min point or a max point. So identifying what the shift is would be really, really difficult. Okay? Basically, what you got to do is you got to look at the model you're using, in this case cosine, and then you got to say, okay, cosine starts at the top. So where is my top point? My top point's here at 4 a.m. So I'm going to make my cosine start there. Okay?
How do we know that the max isn't like 4:30 a.m.?
We don't. But that's the thing when we're taking realistic data and trying to fit it to a model. We're acknowledging the fact that, you know, unless we sat out here all night measuring like every minute or something, you know, we're going every 2 hours, so we're approximating where it would be. Okay? Yeah, Liam?
So if you would have done the sine, it would have started at the min point at noon and then go up.
Well, no, if we had done sine, where sine starts on the midline, we would have to try to figure out what that is. And the fact of the matter is, based on our data, you know, I know it's before 2 a.m.,
Yeah.
but I don't know where it equals 6.1. So that's why I chose to use cosine, because I knew I was going to treat this as a max point, so I could use that. Okay. All right. So actually, at this point, we have everything we need, believe it or not, to figure out our model. Okay. Let's think this through. Okay. If I know my period is 16 hours, the period.
Is C over B.
No, the horizontal shift is C over B, right?
Oh.
What's the period? The period is
2 pi over
2 pi over B. There we go, good. So, if I solve this, multiply by B and divide by 16, I'm going to get B equal to,
Pi over 8.
good, pi over 8. Alright? And then, if this is C over B, if 4 equals C over B, now that I know that B is pi over 8, I have 4 equals C over pi over 8. So I multiply by pi over 8, and what do I get for C?
Pi over 2.
Pi over 2, very good. Okay, so check it out. Now we have everything that we need for our model. Okay, so our model is y equals d, which we said was 6.1, plus A, our amplitude is 5.2 cosine of pi over 8 times x minus pi over 2. There's our model right there. Okay? So you've really got to know that, hey, period is 2 pi over b, and, you know, my horizontal shift is c over b. I got to know that my amplitude is half the distance between the max and the min. But my vertical shift is going to be halfway between the max and the min. Alright, so we got to know when to subtract and when to add. Okay? And then the rest of it is kind of logic just based on your knowledge of that original cosine function. Alright? Knowing that, hey, from the max to the min is going to be half the period. Alright? So, at this point, now we can answer a question like this. This is why models like this can be made. Let's say for this particular dock, okay, this is the model. We can now figure out what time of day it's going to be safe to moor your boat or to pull your boat up to the dock based on how much water your boat needs in order to float. Okay, we don't want to hit the bottom. So this boat needs at least 10 feet of water in order to float. So
Y equals 10.
we're going to let y equals 10. Now, we haven't learned how to solve these equations yet, but we can solve it using using our calculator, just like we solved ones in the last unit with our logarithms that weren't able to be solved algebraically. How would we do this?
Wait, solve it algebra.
No, how would we solve it with our calculators?
You just make a.
Hang on.
We can graph it like y equals 10 and then y equals that side of the function.
Okay, good. Yeah, put y equals 10 and put y equals that side of the function. All right, so get your calculators out and actually do this. This is something that you'll need to be able to do, okay? Why isn't this? Oh. Now, guys, the most challenging part of this, I'm going to tell you right now, is getting your windows set properly. Okay? So we're going to let y equals 10, and then another one, we're going to make 6.1 plus 5.2 cosine of pi is above the caret here. Pi over 8x minus pi over 2. By the way, writing it like this, pi divided by 8 times x, it'll do what we want it to do. If I wanted 8x to be in the denominator, I would have to put parentheses. Okay? So you can just type it in pi divided by 8x. Okay, and then I need to close the parentheses there. And now, before I hit graph, let's think about our window.
Where is pi?
Pi is second
Oh, okay.
caret. Alright, so let's think about our window. We want to do one full day, right? Let's look at one full day. So, what should we do as far as our time goes?
15.
Why?
It's like the eyes was 11.3. But push a little bit higher.
Okay,
Oh,
for our Y's.
Time would be like 12 or so. So, a little more than 12.
Well, it says what time of day, or no, it says what time in the evening can it safely dock. So if we go from 0 to 12, is that going to be enough?
No, you have to go from 12 to 24.
0 to like 18.
Well, 18 is 6 in the afternoon, right? Or 6 in the evening.
It's good enough.
Well, how do you know?
12.
Okay.
You
Why
try.
not like do a full day here, guys? Let's do like
24.
0 to 24, okay? Or you could even do like 0 to 30, you know, kind of go, maybe it's a little bit overnight a little bit. Because we saw, although here we saw it's like down at the bottom, but, okay? Just to make sure, I'll go from 0 to 30. Oh wait, on my x's, sorry. 0 to 30. And then what Alec was saying about the y's is right. You know, it goes up to an 11.3, so maybe going up from 0 to 15 would give us a nice view of the graph. Okay? So now we can hit graph. There's y equals 10. Alright. And there we have it. Okay? There we have our graph.
And then you can find the intersections.
Now we can find the intersection points, okay? So, number second, calculate. Number 5 is intersect. First curve is the line, second curve is the cosine function. The guess is right there. So the intersection would be at 2.23. Okay?
Mine's at 2.16.
Yeah, that's vortex also.
How did you find the dot?
Wait, hang on 1 second. Everyone, real quick, hit mode.
Oh, ours in radians.
Are you in radians?
Wait,
Yeah.
Yes.
Oh, I see that.
wait, where's mode?
Oh, yeah.
Left.
Oh, you know what?
No, that's.
I'm missing the. Hang on, I'm missing the 1. It didn't pick up the 0.1. That's why. Okay. What did you guys get for that first one?
2.16.
2.16. Okay, so at 2.16, we're crossing 10. 10 hours, alright? Or 10 feet
No.
deep, sorry. Okay?
It's supposed to be radiant or degree.
I'd put it in radians because we use 2 pi right
That's
here.
what I thought, yeah.
Okay?
Yeah.
Put it in radians because we use 2 pi. Alright, so 2.16 is our first time. Okay? Now, it's going to be between 2.16 and right here. Okay? Did you guys get this one?
Yeah, 5.84.
Okay, 5.84. Okay. Now, are those in the evening?
No, those are morning.
No, those are early morning. 2 a.m. to almost 6 a.m., right? 2 a.m. to 6 a.m. about. Alright, so we actually need the ones over here. Okay, so if we come over here,
18.16.
18.16.
So it's about like 6:15 or so.
And our last one is 21.84. Okay? 21.84. What was the first one? 18 point.
16.
Okay, so good. There we have. It's somewhere around 6:10 p.m. This is almost 1/6, and 1/6 of an hour would be 10 minutes. So about 6:10 p.m. until 21 hours is, what is that, 9 o'clock? Yeah, 9 o'clock, so 9, and then 0.84 of an hour. What's 0.84 of an hour?
50.4 minutes.
50.4, okay, so about 9:50 p.m. Okay, so it's safe for our boat to dock from 6:10 p.m. till about 9:50. So just to be safe, maybe we would say 6:30 to 9:30. You know, yes. Where's your equation?
I didn't get this stick out so far. The safety hazard. Actually. Yeah, like you may want them on it.
Oh, you have an extra like pi over 2 minus 10
Breaker on
here.
one, and then it's useful.
I should have. But like as I'm going into my desk, like,
Where's like your, oh, here. You had some extra part of the graph. Okay,
oh, did he put the
that's why. So then you gotta go, here you'll punch in 10, okay, hit draw, okay, but you need to set your window. So your, window, your x, we're gonna go from 0 to like 30 hours, okay? Alright, so that's giving us enough time in the day. And then the y, we need to go from 0 up to like 15,
We're making the test.
okay?
That's what we did.
And now we're actually able to see it, okay? Does that make sense? You gotta adjust your window.
And calculate.
Okay.
And a hard drive calculator.